welcome to my YouTube channel. My name is Amandeep Singh. So this is the question of the day. So which is let an be a sequence of real number such that mod of an plus 1 minus an is less than equal to n square upon 2n for all n belongs to natural number. Then option A is sequence an may be unbounded. Option B, sequence an is bounded but may not be converged. The sequence has exactly two limit points. Okay, the fourth option is the sequence an is convergent. Okay, this question can be solved in two ways. So first way is by discarding the options, and second way by learn the result. Okay, so we solve it both by two ways. Okay, so first way is to solve by discarding the option. Okay, so for which we let a sequence which satisfies that condition. Okay, and discarding the option by this particular sequence. Okay, so let because this particular difference are less than equal to n square upon 2n. So let us this sequence an are like 1 upon 2n, where n belongs to natural number. Because if we put this value in that result, then these are okay. Clearly, it is less than n square upon 2n. Okay, because in a numerator there are n square, and in denominator there are only 2n. Okay, so clearly, if we take the difference and taken the mode of this difference, then definitely it is less than equal. It is less than n square upon 2n, because in a numerator there will be n square. Okay, so therefore this particular sequence satisfies that result, so therefore we can take it. Okay, so now clearly if we see it, then clearly it is bounded, because if we put the limit n approaches to infinity at an, definitely it will be 1 upon 2 raised to power infinity, means it is 0. Clearly it is bounded. Okay, so okay, because we have to check whether it is bounded or unbounded at a boundary point. Okay, so boundary point of a natural number is infinity, we can say. Okay, and 1. So definitely it is bounded at infinity as well as 1. So we can say that it is bounded. Okay, so that's why option 1 is wrong, because by according to option 1, they say this sequence may be unbounded. So okay, so now clearly uh, clearly this sequence has only one limit point. Okay, so because this is 0, we have already done in previous video what is limit point. Limit point, when we taken the neighborhood of this particular term, like 1 upon 2, 1 upon 2 raised to power square, when we take neighborhood of this particular term, okay, there will be, okay, so when we take this sequence on a number line, so it will be like 1 upon 2, 1 upon 2 to the square, 1 upon 2 to the cube, like difference are very small. Okay, when we take neighborhood of this particular sequence, then this neighborhood will be intersect ओनली सेट एस के साथ तब करेगा इंटरसेक्ट जब ये इसका जो जीरो के विद रिस्पेक्ट टू जब मैं इसका नेबरहुड लूंगा. ओके, सो देन वी कैन से दैट जीरो इज द लिमिट पॉइंट. ओके, सो लिमिट पॉइंट की डेफिनेशन के अकॉर्डिंग जीरो इसका लिमिट पॉइंट है और ओनली सिंगल ही है. बट अकॉर्डिंग टू पॉइंट सी, दे आर सेइंग the sequence has exactly two limit point, but it is wrong. Okay, this particular sequence which satisfies this particular condition has only one limit point, so therefore it is wrong. Okay, so now definitely sequence has one limit point, as well as sequence is clearly monotonically decreasing. Okay, 1 upon 2n sequence clearly monotonically decreasing, clearly empty. Okay, and sequence has only we can say has only one limit point, has only one one limit point. Okay, as well as we can say sequence is bounded. Okay, sequence is bounded, so therefore it will be converged. Okay, so therefore it will be convert, but they are saying in option B sequence may not be convert. So by this option B is also wrong. So therefore option D is true. One of this particular method is by discarding the option. Okay, now the another method is by result. Okay, so the result is if an plus 1 minus an is less than equal to particular x. Okay, so xn, and summation of this xn is convergent for all n belongs to natural number, then this particular, if we take the sequence of this xn, then it is Cauchy sequence. And we very well know every Cauchy sequence are also convergent, so therefore xn is also convergent sequence. Okay, this is the particular result. If an plus 1 minus an is less than equal to xn and xn is convergent, means series of xn is convergent for all n belongs to natural number, and xn is definitely positive. Okay, it is not alternating, because alternating sequence cannot be convergent. Okay, so xn is Cauchy sequence, and if and only if xn is convergent, means xn is also convergent. Okay, so by using this result we can also prove this. So here that type of sequence or that type of condition are given. Okay, now take this term on a series. So clearly if we note this thing clearly, 2n is exponential function, and exponential function are greater than n square, means if we take this term, it is definitely convergent, or we can prove it by uh, this method. This is a Cauchy root method. Okay, so if limit n approaches to infinity are less than 1, then we can say that it is convergent. Okay, so if we take limit, this is a Cauchy root method. If we take limit, so this implies it is 2 raised to power n, and only 2 are left. So this will be 1 upon 2, because 2 raised to power infinity means n raised to power 0. So it is 1 upon 2. Definitely it is less than 1, means this particular series are convergent. Okay, means these are convergent series. So if these are convergent, then my particular sequence, like this sequence, are definitely Cauchy sequence. So if an is Cauchy sequence, then definitely it is convergent sequence. Okay, it is convergent sequence. So therefore we can say option D is definitely true. Okay, so this is the way to solve this question. Okay, if you like my videos, please subscribe my YouTube channel. That's why I will give you more videos like that. Okay, so thank you.